Okay, rules, or so to say, properties of definite integrals. And these are definite integrals. What makes them definite? They have bounds. We will deal with indefinite integrals in the next chapter. Those are ones that do not have bounds, and we'll be dealing specifically with those in a very, very similar manner. And it's much easier to deal with the ones with bounds first. Okay, these properties can be extremely useful when you're trying to solve integrals. Being able to manipulate, they're very similar to like the properties of logarithms and stuff like that. It can make your life easier. Rearrange things, rewrite them in a different manner, change the bounds. So for example, the integral from b to a of f of x dx is equal to the opposite of the integral from a to b. I flip the bounds, I change the sign. If I flip the bounds, I change the sign. That's what that does. So if I have, and if you have, particularly as we're doing it now, where you're dealing with area, and you're doing from the number on your lower bound is actually a higher value than your upper bound, and you want to, okay, I don't know how to do it for an area where I'm going in the opposite direction, fine. Swap the bounds, solve it, and then just make your answer negative instead of positive. Not a big deal. Second one, the easiest integral you will ever solve. The integral from a to a of f of x is 0. If your upper bound and lower bound have the same value, then you have no width, and therefore you have no area. So if your upper bound and lower bound are the same, it is irrelevant what you're taking the integral of. It will be 0. Okay. Number 3 is the constant rule. If you have a constant times a function, you can pull that constant out, solve the integral, and multiply your answer times that constant. Similar to what we did with derivatives, we have properties and rules of derivatives. A constant times a function is the constant times the derivative of that function. Same thing here. This will be extremely useful. There are times when you'll have constants of integration when we're doing particular types of problems. And being able to move that constant in and out to make it easier to solve or more difficult to solve, depending upon your case. You want to rearrange things. If you have a constant, you can pull it out front, solve the integral, and multiply your answer times out. Fourth one, the integral of a function plus or minus another function is the integral of the first function plus or minus the integral of the second function. Okay, so if I'm adding two things, integral of the first plus or minus the integral of the second, just like it was with derivatives. Okay, the derivative of the first plus the derivative of the second, and so on. Okay. The last one, number 5, and this is the one that gets tricky. If I have an integral of the same function, it's all f of x, the function's the same. If I have an integral from a to b plus an integral from b to c, that's equal to the integral from a to c. If my upper bound is the same as my lower bound, and the functions are the same, it's the same as going from my lower bound of the first to the lower bound of the second one. It makes sense when you think about it as an area. If I have, this is my function f of x, okay, and I'm going from a to b and then b to c, well, the area of a to b and the area of b to c, well, that's the same thing as the area of the whole thing, right? So that makes sense. This is extremely useful because it can go the other direction as well. You can pick some arbitrary place in the middle and take one integral, split it into two integrals. We actually did that in here. When you were doing it by area, and yet some of it was below the x-axis, some of it was above. We did that. We already did that. We split it up into two integrals. Took one and split it up, and technically split it into two. One to find the area below the curve, one to find the area above the curve, and then you add your two answers together. We've done this already going in the other direction. This didn't have a rule for it. Now we have a rule for it. Okay? Basic properties of integration. Most of them are fairly simple. You know, this one is one that's extremely useful. Change the bounds, change the sign. Okay, if you've got a negative one, you can always flip it and get rid of the negative if that's what you need to do. These all go in both directions. If my upper and lower bound are the same, obviously the integral is 0. Pull out a constant, add or subtract, do them individually. This one is a tricky one here. Okay, what I want you to do now, get out a textbook. Problem number 1 from your homework, problem number 1 on page 294, I want you guys to work on that. Spend a few minutes working on that. You're going to be using these properties to solve integrals. Okay, take a few minutes and then we'll go over them together. Okay. Oh, that's awfully washed out today. Even the blue's washed out. Okay. Notice that the following properties of integrals are not true in general. The integral of f of x times g of x is not the integral of f of x times the integral of g of x. Just like the product rule with derivatives. Product rule of derivatives is not the derivative of the first times the derivative of the second. Same thing with integration. You can't say, oh, it's this integral times that integral. I'm just going to split them up, you know, this function times that one. I'm going to split them up to the integral the first time. It doesn't work. There's an addition and subtraction. There is no product rule for integration. There is no quotient rule as well. There are other ways to solve them, and we will learn those. That's what a good chunk of chapter 7 is actually about, is how to solve ones that are like that. Okay, there are tricks to them. Okay, and there are times you can take the derivative of any function. You get a function, you can take its derivative. You can do the manipulation. The algebra and the rules may be difficult, it may be complicated, it may be nasty, but if you're given a function, you give me a function, I can take the derivative. There are rules. The rules will allow you to do that. Some integration cannot be done that way. Some of it's extremely tricky and extremely hard. I'm not going to give you ones that you can't do in here. And there are some rules of how to do integrals and solve them algebraically that I will not be teaching you in this class. You will learn in another class. It's not something we cover in here. Okay? And if you have a definite integral numerically from one end to the other, you can always do that because nothing else you can pull out your calculator. If you don't have your calculator, there are other rules, and we will actually cover that in here. Okay? So this is one of the things that you need to know how to do. But there are no rules for product or quotient. They don't exist. Okay. Now we get to a part that is actually extremely important to talk about. It's brought up on AP testing all the time. I see AP questions that ask for the average value of a function. It's not covered very strongly in any textbook I have ever seen. Okay? It's not covered in any textbook that I have seen very well. Your textbook has it in there briefly. And an older version of your textbook didn't have it. Older editions didn't have this in there. Not really. They've added it in and emphasized it a little bit more. The average value of a function over an interval. What is the average value of f of x over an integral? You take the integral times the distance over times 1 over the upper bound minus the lower bound. This gives you the average value of f of x. I want to know what the average of f is. It's not the integral of f of x that is my final answer. My final answer is actually the average value of that function. If my function is how many miles I've traveled. Okay, let's change it. If it was my speed, miles per hour, and I had a function that described my particular speed at a particular time. How fast am I moving at a particular time? If I want to find my average speed, I integrate that function and then divide it by the upper, where I started, where I ended, the time I ended to the time I began. It's doing the average. Okay. That's what this does. This gives me the average value of the function. I want the average of f of x. Okay, average value of the function of f. So, for example, what is the average value of the sine of x on the interval from 0 to pi? Okay. I want to know what the average value is. So, graphically, what we're looking at for this is the average value of sine. So, let's see, the sine of 0 is 0, sine of pi is 0, and it goes up and comes back down. So I have my y values. I want to know what's the average value of sine. So the sine of 0 is 0. The sine of pi is 0. The sine of pi over 2 is 1. The sine of pi over 4 is root 2 over 2. Okay, it doesn't grow in a nice steady straight line, so I can't take, the distance between these 2 points. I got a curve. At some point, the curve is steeper than others. So if I want to find what sine is equal to, what the average value of sine is, I have to use this rule. So if I want to know what the average of sine is between 0 to pi, then what I do is I take 1 over pi minus 0, the integral from 0 to pi, the sine x dx. Okay. Do it on your calculator. You can't do this one by hand. You do not yet possess the skills to do this without your calculator. You will, not today. Let's see if I can do it in my head. So what'd you get? 2. You can't get 2.
I know you have to, I know how to get
You cannot get 2. It's impossible to get 2.
0.663.
What you give it to you hurts pi.
Can't help you there, but is that technically the right answer?
That would be bigger.
You get like 0.3 or 6.
Take 2 divided by pi and calculate it.
0.636. There we go.
Yeah.
Now I got that.
Yeah, 2 over pi.
Oh, you're just not the part.
So I think it was.
No, you won't.
On tests and quizzes, you saw some quizzes with the lines and direction files.
I prefer, okay. If I ask you this question again, it will be the time where you know how to do this without your calculator. I will want the exact answer. If it's one where it's on the calculator, if it's a calculator portion of the test, you may give me a decimal. If it's on the non-calculated portion of the test, you have to give me the exact answer in terms of pi. This is one of those things where, because the answer was asked, is a decimal okay? Depends. Depends upon where it is in the equation. On the AP exam, this would most likely be a non-calculator question. But it could be a calculator question. If it's a calculator question and not multiple choice, they would accept either one. either 2 over pi or 0.6, blah, 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 blah. And remember, at least 3 decimal places. At least 3 decimal places. You go less than 3 decimal places, you will get it wrong. Even if those first 2 are right. Okay? But if it's on a non-calculated portion, and you will learn how to solve this, because that's what I did, without the calculator. Questions? All right. So then the second part of the equation, what does it say? Where does this function achieve its average value? So what they're basically saying there is, that's my average value. Where is the sine of x equal to 2 over pi? Now this you have to use your calculator for. You absolutely have to use your calculator for. You cannot do this by hand. Because what you're doing is, how do you solve this? How do you solve for x? You use the inverse. So that means x equals the inverse sine of 2 over pi. And there is no, you can't look this up somewhere on your unit circle. It is not one of the unit circle values, so you would not ever be expected to do this by hand. This would be a calculator question. 0.69. Is that right? 0.6920 can't be. Okay, 0.6 what?
0.690.
Oh, 0.6901. Okay, 0.6. I thought you were saying 6.9. No, I can't remember. So no, yeah. Does it actually achieve it at another point? Yeah, because it does it right here. What you're saying is it's like, okay, this is pi, right? So that's 3 point something, 3.14. You're saying, let's see, so you're saying it's right about here is where it achieves its average value. Is that the only place where it achieves the average value? No, it's got to hit it over here as well. Same thing. Average value is there. It hits it in 2 places. You maybe no, because we're only doing that one interval.
Yeah, it's a
That one interval. But there are 2 places within that one interval it does happen. Okay, something to be aware of. Okay. No, I just